yourself wondering how, a complex piece of software actually comes into existence?
Yeah, it seems almost magical sometimes, right?
Totally. So today, we're kind of cracking open the code, diving into the very beginning of a software project.
Think of it as your shortcut to understanding that technical foundation.
Exactly. The stuff everything else is built on.
Right. We usually just see the polished final app, but that journey from just a raw idea to actual working code, it's, well, it's a structured process and a pretty fascinating one.
And we've got some great source material for this. It's a session overview called From Idea to Code DevOps Journey Begins.
Comes from a lead instructor. It lays out like a 45-minute learning session, really detailing those critical first steps.
Precisely. So our mission today, our deep dive, is really to dissect those foundational technical bits.
Starting with, say, a founder's concept.
And taking it all the way to the point where developers are actually writing and sharing that initial code.
And understanding this first phase is, well, it's pretty fundamental if you want to get the bigger picture of software development and, the whole DevOps world.
Absolutely. So let's kick things off at the very beginning, the idea itself.
Okay. So imagine a startup founder. They spot a need. They think, hey, software could solve this.
The material gives us a really concrete example, which helps. What's the problem they're trying to tackle here?
It's actually a pretty common one. People just forgetting to drink enough water, staying hydrated.
Ah, yeah. I could probably use that myself. So the founder comes up with an app idea, HydrateNow.
Simple name, straightforward concept, a potentially useful tool.
And even at this early stage, the focus is on getting something valuable out quickly, isn't it?
Exactly. That's where the minimum viable product, the MVP, comes in. What are the absolute must-have technical features for version 1?
Good point. It's not about building everything at once.
No, it's about testing the core idea with actual users first, before you sink tons of development time into it.
Makes sense. So for HydrateNow, the MVP features are hourly reminders.
Okay, prompts to drink.
A way to log how much water you've actually drunk each day.
Some kind of tracking mechanism.
And a leaderboard. Adds a bit of fun, maybe some friendly competition.
Right, a touch of gamification. So that's the core function set, enough to launch and learn from.
But these ideas, even though they're user-focused, they need to become really specific technical tasks for the developers, right?
Absolutely. And that's where user stories are, well, essential. How do they help with that technical translation?
You're shifting from just talking about features to defining exactly what a user needs to do.
Which really helps avoid building the wrong thing or misunderstanding the requirements.
So let's unpack the technical value there. User stories give you that structure. They frame features from the user's viewpoint, what they want, why they want it.
And there's that standard template, isn't there?
Yeah. As a type of user, I want to perform some task so that I can achieve some benefit.
Simple, but powerful. And the material gives us specific examples for HydrateNow, right? The actual stories that become dev tasks.
It does. Like, as a user, I want hourly hydration reminders. Super clear function.
Okay.
And as a user, I want to track how many glasses of water I drink per day. So that nails down a data requirement, logging and showing data.
Got it. So these stories are like the building blocks of the work. And how do teams typically manage these technical tasks? Keep track of everything.
Well, the overview points to tools like Jira or Trello. Very common.
Right. Those platforms let you organize all the stories, figure out what's most important, see who's working on what.
Exactly. See how things are moving to the whole development process.
Okay, so that leads us nicely into the bigger picture. The technical strategy for actually building this thing, the tech lead comes in now.
Yeah, the tech lead starts outlining the framework. And the key concept here is the Software Development Lifecycle, the SDLC.
Ah, the SDLC. Provides that sort of sequential structure for everything technical involved in building the app.
Right. You've got those standard phases: planning, analysis, design,
implementation, testing, deployment,
and maintenance. And it's really a cycle, isn't it? It keeps going.
Definitely. Especially with Agile approaches, things are dynamic. Which brings up another point from the material, Agile backlog refinement. What's the technical importance of that?
Think of it as keeping the to-do list clean and organized.
Yeah, like continuous housekeeping for the backlog.
Exactly. The team regularly goes through the backlog of user stories, grooming them, making sure they're clear, they have enough detail.
And prioritizing them too, right? Based on technical needs or business value.
Right, and estimating, how much effort each one might take. sometimes breaking down bigger stories into smaller, more manageable technical chunks.
So everyone understands what NASA needs doing and roughly how complex it is, helps avoid surprises down the line.
Definitely. Now, before anyone actually writes code, there are some big technical decisions. The tech stack.
Ah, yes. Choosing the tools and technologies. The source mentions the initial picks for HydrateNow. What are they?
Okay, so for the front end, the part the user sees and interacts with, they chose React Native.
Okay, so that allows for building apps for both iOS and Android from, like, one code base.
Pretty much, yeah. Saves effort there. Then the back end, the server-side logic that's Python, using the FastAPI framework.
FastAPI, known for being fast and pretty efficient to work with, right?
Exactly. And for the database where the data actually lives, they went with MongoDB.
A NoSQL database. Gives you flexibility, especially early on.
Right. So those are the core technical choices. Decisions with trade-offs, like
Yeah.
you said earlier, performance, how fast you can build, how it scales.
Okay, groundwork laid. Now we get to the coding part. What are the very first technical steps a developer takes to actually start building, say, the HydrateNow backend?
So the material walks us through it. Developer fires up their code editor, VS Code in this case.
Mm-hmm.
First technical commands are just setting up the workspace, making a directory, MCD or HydrateNow backend,
Okay, simple enough.
then navigating into it, CD HydrateNow backend.
Standard stuff. And then comes a really crucial step, creating a Python virtual environment. Why is that so important, technically?
It's all about isolation, like having separate toolboxes for different projects.
Ah, okay. So the library is needed for Hydrate. Now don't mess with anything else on the developer's machine.
Precisely. You avoid those dependency conflicts. The command is python-m-env,
That creates the virtual environment.
and then you activate it.
Yeah.
Source bin bind activate on Linux, Mac OS, slightly different on Windows.
Got it. So now you're working inside this clean, isolated space for the project. What's next? Installing the actual libraries needed.
Yep. Using Python's package manager, pip. The command I mentioned is pip install FastAPI Unicorn.
So that pulls in the FastAPI framework itself and Unicorn, which is the server needed to actually run the FastAPI app.
Correct. Environment set up, dependencies installed. Now the developer can write the very first bit of code. The source shows us main.py. What's this initial code doing technically?
It's pretty minimal, right? Just setting up the absolute basics for the backend API.
Yeah. It imports the FastAPI class, creates an app object.
And it defines just one route, the root endpoint, using that at app.get decorator thingy.
Right. And when you hit that endpoint, it just sends back a simple JSON message. HydrateNow API is running.
So it's basically a heartbeat check, proof that the basic setup is working.
Exactly. Foundational verification. But, okay, one developer writing a tiny file is one thing. Real software development is teamwork.
Mm-hmm. Which means you need ways to manage code changes from multiple people. How do teams do that without stepping on each other's toes?
That's where version control comes in. Absolutely critical.
You mean tools like Git and platforms like GitHub?
Exactly. A senior engineer in the material really emphasizes this. Git is the system that tracks every single change locally on the developer's machine.
Okay, like a detailed logbook for the code.
Perfect analogy.
Yeah.
And GitHub provides the central place, the remote repository, where the whole team can share the code, work together, see the history.
Right. So the material then shows the specific Git commands the developer uses after writing that initial main.py. Let's break those down. First one.
First up is git init. That command initializes, or sets up, a new Git repository right there in the HydrateNow backend folder. Creates the hidden.git directory where Git stores all its tracking info.
Okay, repository created locally. How does the developer tell Git, okay, I want these files to be part of the next save snapshot?
That's the git add that command. The add part stages the changes, prepares them to be committed. And the dot just means add everything in the current directory.
Staged, ready to be saved. What's the actual save command in Git, the commit?
Right, the commit. It takes that snapshot of the staged files, and crucially, you add a message explaining what changed.
Ah, the commit message, important for understanding the history later.
Definitely. The command shown is git commit -m, initial commit, HydrateNow API base. The dash lets you type the message right there.
Okay, so now that initial code is saved locally in Git's history, but the rest of the team can't see it yet, right? How does it get to GitHub?
Good point. You need to connect the local repository to the remote one on GitHub. That's git remote, add origin, https.github.com, HydrateNow-teambackend.git.
So origin is like a nickname for that long GitHub URL.
Exactly. It's the conventional name for the main remote repository.
Gotcha. And then there are a couple commands about branches.
Yeah. First, git branch -m main. This just renames the default branch. It used to often be called master, but main is the standard now.
Okay, good practice. And the next one?
Git push -issue origin main. This is the command that actually uploads the local main branch and all its commits to the remote origin repository on GitHub.
And the .u part?
That sets up tracking, so next time you push or pull from the main branch, Git knows origin is the place to go. It just simplifies things a bit.
Right, so now the code is on GitHub, the central hub. The senior engineer really stresses GitHub's role, doesn't he?
Absolutely. It's way more than just storing code. It's where code reviews happen, where people contribute.
Where you can see the whole history, track issues. It really enables that collaborative workflow.
Totally. Fosters transparency, keeps things streamlined.
Okay, so initial code is up. Collaboration begins. The material describes someone starting a new feature. What's the typical technical process for that, using Git and GitHub?
Well, standard practice is you don't work directly on the main branch. You create a separate branch for your feature or bug fix.
Why is that?
It keeps the main branch clean and stable. You work on your changes in isolation. If something breaks, it doesn't affect the main code base immediately.
Makes sense. So how do you create a new branch?
The command is git checkout -b feature log water entry. The -b creates the new branch, feature log water entry, and checkout switches your working directory to it immediately.
Okay, working on the feature branch. Developer writes the code, commits the changes to that branch. Now, how do they get those changes back into the main code base?
That's where the pull request comes in, or PR.
Ah, the PR. So it's basically a request. Hey, team, I've finished this feature on my branch. Please review it and merge it into main.
Exactly that. The example title is Added Water Intake Tracking Endpoint Needs Review. Tells everyone what it is and that it needs eyes on it.
And the PR isn't just a notification, is it? It kicks off a critical process.
Absolutely. It triggers the code review.
Yeah.
Other developers look at the code in the PR.
What are they looking for?
Oh, potential bugs, ways to improve the code, making sure it follows team standards, checking if it actually does what the user story asked for.
And the example mentions a reviewer adding a test case.
Yeah, suggesting that before the code gets merged, a test should be added. Highlights the importance of testing baked into the workflow.
Right. Ensures quality. The material also mentions Git branching conventions briefly. Things like feature, bug fix. Is there a technical reason for those names?
It's mostly about clarity and organization. When you look at a list of branches using prefixes like feature or bug fix or hotfix, it immediately tells you the purpose of that branch. Just makes managing the repository easier, especially with lots of branches.
Okay, so team convention for readability. And what about code review etiquette? Sounds less technical, but are there technical implications?
Oh, definitely. Good etiquette keeps the process smooth and constructive. It means giving clear, specific feedback, not just this is bad, but why.
Right. Focus on the code, not the person. Be respectful.
Exactly. It fosters a better collaborative environment, which ultimately leads to better code quality because people feel comfortable giving and receiving feedback.
Makes sense. And finally, in this initial phase, a quick mention of GitHub Actions for CI, continuous integration. What's that about, technically?
CI, continuous integration. It's a practice where every time code changes are pushed, especially to branches involved in PRs, automated processes kick in.
Like what kind of processes?
Building the code, running automated tests, that kind of thing. GitHub Actions is a tool built into GitHub that lets you define and run these automated workflows.
So the goal is to catch integration problems early, make sure new code doesn't break existing stuff.
Precisely. It keeps the code base healthier and more stable throughout the development process. Early feedback loop.
Wow. Okay. We've actually covered a lot of technical ground there. From just the initial idea all the way to getting code onto GitHub and starting that collaborative loop. Can we do a quick technical recap, the key steps and tools?
Sure. So we started with translating the idea into those specific technical requirements, the user stories.
Right. Managed in Jira or Trello.
Then the SDLC provided the overall technical plan.
Planning, analysis, design, etc.
Then the developer setup. VS Code, the virtual environment for isolation, installing dependencies like FastAPI with pip.
Writing that first simple API endpoint in main.py.
Then the crucial step, version control with Git, init, add, commit.
Connecting to GitHub, remote add, push.
And finally, the collaborative workflow, creating feature branches, checkout-b, proposing changes via pull requests.
Which triggers code review and maybe CI checks via GitHub Actions, eventually leading to merging the code.
That's a pretty solid summary of the initial technical journey.
And the main tools introduced here were...
Let's see. VS Code for editing, Git for local version control, GitHub for the remote collaboration hub, FastAPI for the backend framework,
Python pip virtual environments,
Jira Trello for tracking, and that little preview of GitHub Actions for CI.
Yeah. The material even sums it up visually, right?
It does. A flow. Idea leads to requirements. Requirements drive the code.
Code is managed by Git.
Git interacts with GitHub for collaboration.
GitHub is where pull requests happen.
PRs lead to review and eventually merge back into the main branch. It's that cycle.
A continuous technical loop, and this whole session, this initial phase, it's really just the beginning described in the source material, isn't it? Sets the stage for more advanced topics.
Oh yeah. The overview hints at what comes next. Getting deeper into Python command line tools, more advanced Git and GitHub workflows.
Containerization with Docker, setting up automation pipelines with Jenkins or Ansible.
Deploying to the cloud, like AWS or using Kubernetes.
Oh, no.
And of course, security monitoring.
All leading up to a capstone project where you'd presumably tie all those technical skills together.
Exactly. So, quite a journey ahead.
But understanding these first technical steps, the ones we talked about today, is so important, even if you're not the one writing the code.
Why do you say that?
Because it gives you real insight into how software actually gets made. The process, the collaboration, the tools, it demystifies it a bit.
Yeah, you start to see the structure and the technical discipline involved. It's not just magic.
Right. It shows that a rigorous journey an idea takes just to become that first version of an application.
Absolutely. So every app you use, every website you visit, it went through some version of this initial technical process we just walked through. Hopefully this deep dive gave you a clearer window into those first crucial steps.
Now, just a couple of important notes before we wrap up. The content of this deep dive is based on material created, curated, and compiled by Kel Parpies. They used AI-assisted tools, including ChatGPT, to help ensure clarity, quality, and relevance in an educational context.
Right. And all the content presented here, the structure, the explanations, everything, it's the exclusive intellectual property of Kel Parpies.
So any unauthorized use, reproduction, distribution, sharing, or adapting any part of this content without express written permission from Kel Parpies is strictly prohibited.
And violations will be pursued under applicable intellectual property laws. Just need to make that clear.